Hi everyone. Like I mentioned previously in my article, that how the data can impact your AI or ML model. In this quick video, what I'm going to show the same thing that I have written in that article that will help you to test at your end that why we are claiming that the data is the core of each ML and AI model. And most of the time, I would say 80% of the time, the engineers work on preparing the data instead of working on the models because the mathematical the models AI or ML alike, they are mathematical equation, and based on equation the system will generate the output. And I'm going to show you in this video how your data is playing the key role in generating the outcome, and if your data is not correct or ready, it's not going to produce the right outcome. So let's start by running a very simple regression example. I'm going to use the torch, which is part of the PyTorch, is the NN library, which works with the neural networks, which is the core of all the latest AI technologies, regardless whether it's going to be deep learning, it's going to be Gen AI, a generative AI, or any other machine learning model that you are using in your environment. If you are using, for example, any out of the box models, that the base is neural network, right? So I'm gonna use a very simple neural network which is using the linear equation and predicting the output using the regression. So you can see, because we are talking about regression, so we're going to have a linear line, and what I have taken as an example is the relationship of the study hours and actual scores. Like the student, whatever their study hours are, based on that we are predicting their scores in the exam. And I've just created a random equation, which is y is equal to 9x plus 10. What does it mean? That y is the actual score, and x here is the variable which we are providing. So it's a single input linear equation that we are going to use, because I just want to show you the importance of the data. So whatever x we are providing, the system is going to behave on that, right? So at the moment, we have a very clean data that we have generated as part of our PyTorch, and then we are feeding it without any noise. So you can see I haven't added any noise. Sorry, let me just comment this one. So I haven't added any noise. We have a very simple linear equation that we are going to use, and the rest is the technicality of the model, which I'm going to describe in another video. In here, I just want to show you what I'm going to do. I'm just going to run, let's say, only for 500 passes to see whether I'm going to get a good straight line for my data. So let's run it. So let's see what it comes. It's just preparing my model. Now it's running. So you can see here the loss is the key, because loss tell you that how accurate your model is. So you can see we started with the loss in here because we are talking about the regression line. So initially started with a random value, which most probably be 0, and based on those weights the model start adjusting the line, and you can see how quickly it converts, because it's the neural network, it learn very fast. So in your I think in our 200 epoch or run, the model converges to the minimum loss, which is 0.45, and then the further refinement is very low. You can see after 200, the loss function is only changing in decimal places. So let me just show you the line. So you can see that's the ideal line, which is not possible in the real time environment on our real life, but you can see the line is exactly on the points which we are expecting, right? Because it's a synthetic data, it's the ideal data set. Now what I'm going to do, I'm going to add some noise in our data, and that's going to be a small noise, and we'll see what's the impact of this noise on the outcome or on the loss function. So let me come in here, let me uncomment the noise. So we're just adding some random data. we are adding it into our equation. So the actual scores are going to be distorted, because based on that, we will see that how best we can fit our line, right? So what I'm going to do, just going to use this up to 5. So we're going to generate a random number based on the x that we are using in here, and then we are just multiplying it by 5 and adding it into our actual score. So that just generates some noisy data into our actual data set. So let's see. But that's it's very small noise, right? But you're gonna see the impact straight away. So the model is present. So now you can see the loss function is immediately jump from point 0 point something to now 28. So you can see how the noise is impacting, how the incorrect data is impacting on the outcome of the model. And you can see the same thing in here, like the line we are trying to fit into our data. It's now passing only some of the points. So it's very different from the previous line, because now we don't have the ideal data, we have the noisy data, and we are going to find the best line with minimum loss to fit it into our given data set, right? And based on this line, we can definitely predict the upcoming or unseen data points. Okay. Last but not the least, let me just do a large noise. For example, we are going to now add really dirty data into our model, right? And then we'll just keep an eye. So now the loss function has jumped from 0 point something to 28. Now, if we add a large noise, you will see the outcome by yourself, that how it impact on the loss function as well as on the line as in the chart. So you can see in here the line is now passing to less points. It's not a very good line, but because we have a lot of noise, a lot of garbage in our data, so you can see that that's the whole point. So in ML or AI industry, in the roles, you're not expecting to go and work on the models straight away, because mostly your time has been consumed on the data. You're gonna prepare your data, and then that data is going to feed into the machine learning model, and you will get the outcome. But this cycle is iterative, like you feed the data, you get the outcome, you compare, you consult with the business users, you find out whether the outcome is correct or not, and then you repeat the cycle. But 80% of your time is going to spend on preparing your data, which we generally call data wrangling, where you get the data from the sources, you find, you clean, you prepare the data, and then you feed it into your model. Because if your data is coming with noise, you are not going to get a very good outcome from your model, and you're going to find out by looking at the loss function. So now you can see the loss function has jumped from 28 to 708. So you can see how sequentially, or how exponentially it increased based on the incorrectness or the dirty data included in the main data set. So hopefully that will convey the concept that I'm trying to convey as part of my article. So I thought it would be good to actually show you with the actual model and actual code as well. So let me know if you have any question. But yeah, prepare yourself for all the AI or ML jobs. Your main job is going to prepare the right data for your models. Thank you very much.